41 is infrared detector. This is the first project in which the infrared module has a direct purpose. I used it in at least one other project, but just as like a support for other components. For this project, we will need an infrared remote control, such as any TV, DVD, or stereo remote that you'd find in your home. Infrared light is an invisible type of light that is produced by the sun, some house lights, your body, and many remote controls. This remote control, which I got from a boombox with a built-in TV, has an infrared LED on it. And the light it gives is not invisible, but it will make this red LED come on. We will point the remote at the project and hold down one of the buttons. The LED comes on, and I'm not touching anything on the circuit. When I release the button, the LED goes off. And it doesn't matter what kind of buttons you push. Any button you push is going to activate the circuit. Sometimes this circuit may activate without a remote control because of other sources of infrared light. If this happens and it's interfering with the demonstration of your project, move to a dark room. 42 is audio infrared detector. This project has the same principle, except it will now make sounds instead of producing light. We will need an infrared remote control, which I have right here, and we will point it at the infrared detector. And the sound will play as long as a button is pushed on the remote control and it's aimed directly at the infrared sensor. Now, the adjustable resistor is used to set how long the alarm plays for upon releasing the button on the remote, but it will only play over a very short range. The capacitor is storing energy for the alarm, and when you release the button on the remote control, it will send a brief amount of power through the circuit to make the sound until it runs out. And then you have to push the button again to charge the capacitor back up. I will explain about the capacitor more in later projects. Now we can adjust the sound by switching the resistor. I was using the R1 resistor, but now I'm going to use the R3 resistor, and let's see what happens. The sound is a lot different. It's more low pitched. And also, the sound has a wider range on the adjustable resistor now. And it plays longer too. Now, like the previous project in any of the ones using the infrared detector, the circuit may activate without remote control due to other sources of infrared light in the area. So to solve this problem, move to a dark room. 43 is photo infrared detector. As you can see, I don't have the actual infrared module, but I have the photo transistor with the attachment holder above it. And now we will aim the remote control directly at the photo transistor, and let's see what happens. The LED flashes. Release it, and it turns off. and you can adjust the sensitivity by moving the RV. It adjusts the sensitivity of the phototransistor, which reacts to light. Not sure if this is the most sensitive or least sensitive setting. This is the most sensitive setting here. That's least sensitive. Now, the phototransistor can detect any type of light, which includes infrared light. So, even though it's not visible, the phototransistor will respond to it and turn on this circuit. 44 is photo audio infrared detector. This circuit uses the same principle as the previous one, but now we're using the sound instead of light. We will move the adjustable resistor. Right now I think it's on the highest sensitivity level, and we have the fiber optic tree holder on the phototransistor, and we will point the remote control above the phototransistor. And now the speaker makes an unusual sound. As soon as you release the button on the remote control, the sound stops. Actually, this is the lowest sensitivity level, not the highest one. Now it's the highest one. Because when I hold the remote further away from the circuit, it will still activate on this setting. For Project 45, photo audio infrared detector number 2, we'll replace the C2 capacitor with the C4 one. And now, the sound will last longer after you release the button on the remote control. It kind of sounds like a siren, in a way, that the sound slowly fades out. One more time. And there you have it. 46 is strobe effects. This is a very special circuit, and we built the following circuit and hooked up the white LED using the black and red jumper wires. The most unique feature of this circuit is that we are going to use the disc holder with the following color disc. This kit comes with 5 of these in all, but we are supposed to use this one. And we will insert it on the disco motor, and then turn on the slide switch. Now we're going to shine the white LED, which is flashing at a very fast rate now, on the disc, and watch the patterns. We can also adjust the rate at which the LED flashes by using the RV resistor. Now, it's hard to hold the LED over the disc and move the adjustable resistor while I'm holding my phone, so I will just slowly increase the rate at which the LED flashes. It's on continuously, so it's kind of bright for the camera. This is the lowest flash setting. But you can see how the patterns behave. Now we're going to hold down the press switch, and this will speed up the motor. And we can see how the pattern changes now. The disc is spinning so fast that it looks like a blur, But as you gradually adjust the RV lever, the pattern on the disc will appear slow down, stop, and reverse direction. Patterns close to the disc center may be moving at different speeds or in different directions from patterns further than the center. Some patterns are more clear than others. I wish I could slowly adjust the RV lever and push the press switch at the same time, but I can't do that because of the fact that I'm holding my phone too. Holding down the press switch now. And do you notice a difference in the patterns? Release the press switch. See any other differences? The motor should keep spinning after you release the press switch, but if it doesn't, either replace the batteries, or if that doesn't work, replace the R3 resistor right next to the fan with a solid 3-snap wire. Project 47 is slow strobe effects. We're going to use the same circuit, but we'll replace the R3 resistor with the R5 resistor, which is stronger. And then we will turn on the slide switch, and you may have to push the press switch to get the motor to spin. Now, unfortunately, it won't really keep spinning without pushing the press switch in this circuit, so we will have to replace the R5 resistor with a 3-snap wire. I'm going to do that right now. And now it will spin on its own. I'm going to hold the LED over the disco motor, and you notice a difference in patterns. You might be able to see the patterns more easily with this project as opposed to the other one, because the motor is not spinning as fast. Now I'm going to do the LED at its highest setting. Hold down the press switch. 48 is stable strobe effects. We're going to repeat projects 46 and 47, but we will add the C2 capacitor right here using a single snap wire. Here's the diagram for how you would mount it. And then we will turn on the slide switch and adjust the RV settings. This is the lowest setting, and the C2 capacitor does not do anything but hold the motor so that it's more steady when it is spinning. And you should notice if there is a difference in patterns between this project and the previous two projects. I'm just going to use this setting, and I'm going to use this setting for the next 4 projects. 49 is strobe effects 2. We will replace the disc with the one that has 3 colors: green, red, and blue. To replace a disc holder, you might need to use a pencil or another sharp object to pry the disc off of the cover. But be careful so that you don't damage the disc, the cover, or injure yourself. Alright, and now we will observe the disc cover in action. Push down the press switch. Now I'm going to move the lever to the LED to its highest setting. And what color do you see? Now my camera doesn't pick it up like this, but the disc is supposed to appear white because combining the three colors on this disc produces white. When it's not at full speed or at full on the highest setting, you'll probably notice the colors, but on the highest, but when the light is at full brightness, it will appear to be white, at least to your eyes. 50 is strobe effects 3. We will use the swirly rainbow disc and turn on the slide switch. The LED is at its highest strobe setting, and at certain settings on the RV, the colors of the rainbow will be visible. Once again, my phone might interpret the colors differently, but your eyes will probably see them as rainbow. Oh, here you get an excellent view of most of the rainbow colors. And we're kind of near the lowest setting. Not all the way, but I'm going to go there now. You get another good view, but there is more white in the patterns. 51 is strobe effects 4. We are going to use this disc and place it into the holder and turn on the slide switch. What colors do you see when the LED is at its lowest strobe setting? You might be able to see at least some of the colors on the disc. Now I will hold down the press switch. I think I forgot to do that in the previous project, but I am going to put the LED on the highest setting. You can't really see any of the colors on the highest setting. Now I'm going to do the middle setting. Now you may see all the colors: yellow, blue, red, white, and black. Move the RV lever down a little bit more, and you might still be able to interpret almost all the colors. 52 is strobe effects 5, and we will turn on the slide switch. Move the RV lever to its lowest setting, and you can still easily see the two colors. Hold down the press switch, and now move the RV on the highest setting. And look at that. The pattern seems to change a bit. It doesn't look like they are solid stripes now. They have dots on them. Yellow dots on the blue stripes and blue dots on the yellow stripes. Hold down the press switch. Now move the RV lever about halfway. '53 is strobe effects 6. We are going to use this other disc that has the colors red, blue, and green, but in a completely different pattern than the one we used earlier with the same colors. The RV is on the middle setting, and it looks like you don't see red and green, even though you see blue. You see purple and yellow. And that is because of how the different colors are combined. When the pattern is completely blurred, which I think it is, you will see purple, cyan, and yellow. Cyan is like a blue. When you combine red and blue, you're making purple. When you combine green and blue, you're making cyan. And when you combine red and green, you're making yellow. Lowest setting. you actually see a little bit of green in the center. And that's it for the strobe effects with the discs. 54 I am not going to demonstrate, but it's make your own strobe effects, and you can use paper or cardboard and cut discs out of them so that they're exactly the same size as the disc that you can fit onto the holder here. You can draw your own patterns on them or on the backs of the discs here, because they have a plain side. And then you can just simply mount them onto the holder and repeat projects 46 through 48. To make it more fun, you can have a contest with your friends to see who can make the most interesting strobe effects. For ideas, you can look on the internet for patterns and visual illusions. There is no limit to what you can do.